welcome. I'll move on to my first slide. So what I wanted to discuss today is a bit about what I do and what we do at Gamesys. Give you an overview of the current architecture. Obviously, Simon did quite well this morning, but I'll go through that. Some of the historical challenges we faced with Appium. Yeah? Now, it's quite interesting. Historical is 5 years ago, yeah? So it's not that long ago. Give you a platform overview from iOS and Android, and then some additional endpoints, and hope to discuss the future of mobile web testing. Yeah? So some of the tip of the tree stuff that's currently going on. Yeah. Right, so a bit about myself. I've been testing for about 15 years, as a job, a role. To be honest, I've been testing most of my life, taking apart motorcycles and trying to figure out how you put them back together. Last week, I took apart my wife's phone. Needless to say, right now she has a new phone because I couldn't put it back together again. So it's in me to take things apart and figure how they work. Right? So hopefully, part of this talk today, you're going to find out a bit more about how Appium works, how it communicates with Safari and Android and stuff like that. I've worked in insurance, banking, and right now in gaming. I must say gaming is the most interesting one of all. Quite challenging, quick moving, quick pace. I'm originally from Holland. I moved to the UK in 2006, and yeah, just been getting on with it. And I started with Gamesys over 5 years ago. One thing to mention is these are the brands that we're currently testing. I mentioned the ones that are mainly focused on the USA, Virgin Games and Tropicana Casino, the big brands. Unfortunately, they're not in California. Obviously, it hasn't been legalized with gaming, but they do focus on New Jersey and stuff like that. Let's see. The one thing I did want to mention, in our company as well, obviously I was started to contribute to open source about 5 years ago, but in our company as well, we work in an open source fashion. Yeah? So teams have their own repos, which they manage, and drivers that we manage, and other teams can do pull requests in that and actually suggest, look, I want to make this change, are you comfortable with that? And we do reviews with pull requests. So it makes it quite easy to work with each other and to expand that experience. Right. Let's go to the next slide, and I'll give you an overview of what Simon was mentioning this morning. Now, this is how we all know Selenium works. Yeah, we're very comfortable with that. The browser, I say that they provide the drivers, the ChromeDriver, the Gecko driver, and they all use a well-defined protocol. Yeah? So the JSON wire protocol, which is moving to the WebDriver protocol, as Simon was mentioning this morning, has been worked on over years and is clearly defined. Minor tweaks are being made, but it's well defined. One of the things that I will be discussing going forward is, let me actually put the laser on there. So you can see here, in between the drivers, there are different Webkit and remote debugging protocols. And this is where it starts getting interesting. And I'll discuss some of that in a second. Now, one thing you'll find here is there are no dead battery issues. Yeah? And this is what you'll find with real devices. The machine that is running the drivers and the machine that is running the browser are all on the same network. Yeah? So you don't have a physical device that's actually on Wi-Fi, which doesn't have access to your test environment. So none of those problems exist in this environment. It is all clear cut. Final thing, you can run multiple browsers in parallel. Yeah? So there's no problem creating a session and then going off, and if you're running on a physical device, there's no way of running 3 or 4 browsers at the same time. So those are all limitations that you're going to find, obviously, when running on a real device. Was there anything else? I don't believe so. Right. Before we move on to Appium, I wanted to kind of give an overview of how Selenium does its magic. Yeah? So all of us here who've worked with Selenium have used, find the web element, get an attribute, click on this item, But as I mentioned before, I'm one of those people that really wants to get to the nitty-gritty. How does it actually do this? Right? Does anybody know here? How does, obviously other than the people that are contributing, how do you actually, how does Selenium actually find an element? Anybody? No? And I can understand, because I've asked in my company, oops, sorry about that. I've asked in my company, a couple of the senior guys that have been using Selenium for years, how does it do it? How does it do that magic? And everybody's like, well, you just can't find element. Obviously, yeah? But it uses atoms, right? No, not protons, neutrons, and stuff like that. Minor little bits of JavaScript, yeah? And those are used by Selenium, are used by Appium, and by Selendroid. Yeah? So all the interactions that happen with the page happen with these really small bits of JavaScript that are minified. Mention one thing of note, not every action, obviously like something like navigating, requires an atom. Yeah? So the main thing that requires an atom is displayed, is enabled, click on an element. Yeah? And again, I'll do a demo at the end of how the atoms work, because obviously I can't do it here at the moment. But if anybody wants to see it, obviously we can sit down and do it afterwards. Right, how do atoms work? Yeah? Find an element. So if you look in the code, and there's actually, I'll share this presentation afterwards, there's links to these atoms, right? But the way that it works is it injects the atom into a bit of JavaScript, and then you pass the variables that you need to find the element. Yeah? What happens then is that you get a response. Yeah, I found the element. Yeah? And it creates a reference to that element. Now, this is stored locally on the browser under that variable. So if you want to actually test it out, you can see this variable there. Yeah? Now, what you get with this is, once it's done in find an element, if you then try and interact with the element after the DOM is changed, this is where that whole stale element exception comes from. Yeah? Because it's got it locally, it's got a reference to it, you're going to try and click on it, and at that point it breaks. Simply because that's not up to date. Yeah? So this is kind of how that works, basically. Right, continued on. Once you've got a reference to an element, it's the same thing. You've got another atom, you pass in the element that you just have, and you can click on it. Yeah? And the same thing with get attribute. It's as simple as that. Yeah? So simple little bits of JavaScript. Now the one thing I wanted to mention is part of this talk was also about introducing people to how it works, and also mentioning that it's not as difficult to contribute to Appium if you understand how this all fits together. Yeah? So some of the next slides will give you that overview, hopefully, and then you can see how all these components interact with each other. Right. I mentioned about let's see them in action. Unfortunately, as I don't have access to the machine, I can do it afterwards on my machine. Right. Now, how does Appium send these atoms to the browser? Yeah? So this is the next step. We've got these scripts, and we can actually interact with the element. We can find the element. And obviously, in my demo, I would have just copy and pasted that script into the console. How does it get it to the browser? Right? It obviously can't do Control-C, Control-V, as I mentioned. Right. And this is where remote debugging protocols come into play. Yeah? So what I mentioned in the first slide, in between the drivers and the browsers, this allows us to interact with the browser and allows us to do certain things with the browser. Right. Executing JavaScript. Yeah? The protocol that is called, or the method that is called runtime.evaluate. Yeah? And this is it. Right? This is that protocol. And it's clearly defined. You've got these, how do you say that? There's a site for the Chrome remote debugging protocol, and you can see it here. This is the JSON that you send along to the browser, and the browser will respond to that, and it will have executed that value. Yeah? Another simple example is for navigation, page.navigate, and you send along the URL, and it goes off and browses to that page. Yeah? So not rocket science. It's just you need to know how these components interact with each other. Let's see. Right. So now that you have a bit about how the browsers actually work, let's move on to the how Appium uses this and some of the historical challenges that we faced. Right. I always have this conversation with my mom. Things used to be better back in the day. Well, no. Yeah. And 5 years ago, obviously, we started working with Appium, and we really wanted to automate on physical devices because it was really important to us to be able to run it on a real device. So these were some of the challenges that we came across. We were unable to run on Safari with real devices, couldn't really debug, no easy access to the browser. There's a few proxies that have come in since then. Launching and closing Safari. And I'll discuss those a bit further in a second. Painful, really painful. Not all features were yet covered. Now, one of the things to mention is, I don't know if some of you were working with Appium at the time, you try and set a cookie, and the only response you got, not yet implemented. If you wanted to contribute, look at this URL, and please come and help us. And it was fantastic at the time, because it gave a lot of people the opportunity to actually contribute to this greater project. And as Simon mentioned earlier, you do feel you can actually add value to this. The API was also not fully defined. For example, launch app, install app, were stuff that wasn't actually discussed, because at the time, the way that it was working is, when you created the session, it would automatically install the app and launch the app. Right? So we were having discussions around, right, can we separate this? Because we really want that for our testing purposes. And as well, final one, no Appium clients. Those were added, I believe 2014 is when they started adding those. So we had to build our own client at the time. Right, so I wanted to go through 3 of those challenges to kind of give you some ideas of what was going on. Challenge number 1, running Safari on a physical device. I actually posted a question. I'm trying to grab the window handles on the WebView app. And what's funny is one of the people in this room, Jonathan Lips, actually responded at the time, going, it might be challenging at best, possibly impossible. So you come across this and you go, oh, great, this is one of our requirements. Our business wants us to really test on physical devices. I need to be able to run this. How are we going to solve this? Well, luckily, somebody already did. So there was a chap from Google who had implemented the iOS Webkit proxy, and we, did a pull request. Now, if you want to have a laugh, please look at pull request 562 on Appium. There's about 70 commits in there. I came from a Java background. These guys were very, very helpful in saying, okay, in JavaScript, this is how you do it. Yeah, please change the formatting and stuff. The other thing was, it was my first commit, and there was a request, do you mind squashing these commits? And I'm like, squashing what? What are we talking about here? Never heard of the concept. So again, they were very, very good with helping me out. So again, if you've never committed to open source, don't be worried. I've gone through that pain, and it is something that will, in the end, work out, basically. Right, next challenge. So we finally got it working on the device. How do you launch it on a real device, right? Because these were all the challenges that we had to face. It wasn't implemented. It wasn't there. And to be honest, the solutions that we implemented weren't using sensible standards because they weren't implemented in the remote debugging protocols. Oh, hello. Maybe the resolution. I do apologize. For example, we were looking at, can we use instruments to do launching of Safari? Nope. Only apps in debug mode could be launched with Safari, or it could be launched with instruments, right? Can we use remote debugging? No, remote debugging only works when the app is actually up and running, right? So you can't actually do anything with it, right? Can we use an app? And that's where the Safari Launcher app came into play. So the only way to force iOS to launch Safari was to actually take an app and have it navigate to a URL And at that point, you know, the app would go into the background and Safari would be launched. And at that point, you could do, you know, actually communicate with it. And you could, you know, work with the app. One thing to note, and this is where it comes, you know, it becomes very painful as well. You needed a developer, iOS developer program to be able to do this. You couldn't just install an app on Safari. So it wasn't as easy as going, oh yeah, I just want to run my tests on Safari. No, no, no. You needed to buy, how do you say that? A developer program. You needed to get your, actually, let me do the next bit. So you needed the developer certificate. You needed an app ID. And you needed a device ID because Apple only allows you to install the Safari Launcher app on devices that, you know, you have added to this profile. So it isn't as easy as I said. And to be honest, this is still to this day, you know, with the next, with the WebDriver agent, is still the case, right? For us to be able to test a browser on a device, we have to actually be able to install apps. So it's not as easy. This should be easier, right? This should be something that, you know, we shouldn't need that to be able to launch Safari. But again, hopefully over the next couple of years, this will improve. Final challenge, yeah, out of the three. Obviously, there was lots more challenges, but you know, it's something to mention. So we finally got to a point where we were able to launch Safari. Yeah, we were able to actually interact with Safari. And after running 10 tests, I found that I had 10 tabs open. After running 100 tests, I found that I had 100 tabs open. Obviously, Safari at a certain point starts crashing because you have 1,000 tabs open. Doesn't scale very nicely. Right, can we use instruments to close the Safari tab? Nope. Yeah, it doesn't work. Again, as I mentioned, with the, it has to be an app in debug mode to be able to do that. Can we use remote debugging? At the moment, I believe there's only one browser, which is Chrome, with the remote debugging tools, which supports, and I'll mention that in a second, which supports a domain called browser.close, yeah? And allows you to close the tab. But we couldn't do it, and I don't think it's still there. Can we use JavaScript to close the tab? Right. If you try and close a tab that hasn't been opened with JavaScript in Firefox, this is the message that you'll get. Eh? And in Chrome, I believe it doesn't even work. Or can they? Eh? This little bit of JavaScript only works on Safari. Eh? And if you search for this, you will find it in the XEUI test driver and you'll find it in the iOS driver. It is the bit that allows us to close tabs on Safari. Eh? Thing for me is, why isn't there a remote debugging protocol to allow us to do cleanup and to allow us to close this off? Yeah, to this day, this is still being used. And we implemented this 4 years ago. Eh? Right, let's go through those different platforms so we get an idea of how this all fits together, so to say. Oh, wow, sorry. Sorry about that. Scared me even. Right, so this is how we worked with instruments, yeah? And you can see below the iOS Webkit debugging proxy. Yeah? So we have a remote debugger which accesses mobile Safari web view directly, yeah? Because obviously on a simulator we have direct access to the how do you say that? To the simulator and to the web view, so there's no need to go through a proxy. Now, for implementing the proxy, we had to go through a different remote debugger, and we actually had to be able to translate between Webinspector protocol and the Webkit protocol. Yeah. Now, I'll go through that in a second to show you the differences. Right. This is how it is right now. Yeah. So we're still using the iOS Webkit debug proxy to be able to interact with the web page. Now, I've got a next slide, which might be able to change that, but again, to be discussed. As you can see, yeah, we're using the Webinspector and mobile spec, which is what the WebDriver agent is using to communicate with something that runs on the mobile device. So you still need a profile to be able to install on the app, or to install the WebDriver agent on the device. And we're still using the Webkit remote debugging protocol and the Webinspector protocol to communicate with the views. Okay? The only thing that's really changed is we've moved away from instruments, obviously, And we no longer use Safari app or the Safari Launcher app to actually launch the app. Right, so what's the difference between the Webinspector versus the Webkit protocol, yeah? Which is what we're using, one to communicate with the simulator and one to communicate with the iOS WebKit proxy. So there's a few, the way that it works is the Webinspector protocol wraps the WebKit protocol with, you can call it an envelope. Yeah? And what it's adding is an application identifier, a page identifier, a sender key, and a connection identifier. So what it does basically is tells, how you say that? Tells it what web view to run it on. Yeah? So if you've got an app and you've got multiple web views in that app, that will say, yeah, I want you to run this runtime.evaluate, and I want you to run it on that second web view, yeah? Or I want you to run it on the first web view. So it is, quite straightforward. It's both. They're using the same WebKit protocol. The one just has something to wrap to it, add some fields to it. Now, if I go back to the previous slide, well, actually, I'm going to go on to the next slide. As I was doing this slide, I found that there's been some changes which allows us to actually get rid of, potentially, the iOS WebKit debug proxy. Yeah? So if you see, let me see, there, yeah, we're supporting two different protocols. One is the WebKit protocol and one is the Webinspector protocol. Yeah? The only reason why we added the WebKit protocol is because we needed to be able to go through the iOS remote debugging iOS debug proxy to be able to access the browser. Looking at the current architecture, there is actually now an iProxy which allows you to open up a port to the device, right? So technically, we should be able to use the the WebKit protocol to communicate directly with the browser. Question? Possible? Maybe not. Again, it's something to consider. So what I wanted to mention is, as these things happen, right, we can obviously make changes and we can try and we can improve on this product, and this can potentially be a pull request for the future. The reason why I say this is because right now what's happening with this proxy is it's doing a translation, right? So it's translating from, how you say that, the WebKit protocol to the Webinspector protocol, and it's adding these fields. At a certain point, I believe it's between iOS 8 and iOS 9, that protocol changed. There was a field added or a field removed, and that proxy stopped working. So we needed somebody with C experience to update that, and it was really hard to find some guy to do this, and we're like, oh, who can help us? And so it took a very long time to actually make this change to get it back up and working. Whereas if you remove that bit, and you allow the communication to happen directly, then it's much easier to do it. And Appium has the control to be able to change that. Yeah? Right, let's go on to Android. This is much more straightforward. Yeah? So what you can see here is we use the Android debug bridge, ADB, yeah, to be able to launch the app, to be able to communicate with the device. One example I'll show in a second is, with the ADB commands, you can actually retrieve memory info, CPU info, and we extract some of these values to be able to use it for our testing. Obviously, we have the ChromeDriver, which is also using ADB to communicate with Chrome. Was there anything else that I wanted to mention? One of the other things with regards to this is, for everybody that's been testing using the ChromeDriver, I think at a certain point, with stock browsers, it changed, and obviously, the stock browser started becoming Chrome. But obviously, with the ChromeDriver, we should still be able to test on anything that is Chromium-based, right? And it turns out that the Samsung browser, or the S browser, internet browser, is also a Chromium-based project. And it is taking quite a bit of the market. So it is potentially another pull request where we could try and see if we can use the ChromeDriver. And when you pass in, I want to run the Samsung browser, we can actually use that. And it's just because the package or the bundle ID is different, right, that it doesn't currently work. But it is something that can be changed as well. And again, all of this was simply because I went through and started looking at the presentation and how these things all work together. So it is as simple as that, right? You start looking at these things and, okay, can it be done better? Is there another way of doing it? And that's how these pull requests come into play. Now, how does Chrome actually do this? Because obviously, you have the Android debug bridge installed and the Android SDK, but how does Chrome do it? When you go to Chrome/inspect, you can see what's happening on the device. It does it the same way. Yeah, so it's doing port forwarding automatically, and that's how you can actually inspect it on a physical device. Final one, right? Selendroid. This is actually being deprecated, but it's you can see we have a local server that's running. It's following the web JSON wire protocol. Yeah, and that allows you to communicate with the devices. But again, it required you to, oh no, sorry. On Android, obviously to install something on the device, there's no profile needed. Yeah, it's a lot simpler to be able to do that. Let's see. Sorry. Right, so what are the differences between, how do you say that, Selenium and Appium? There's a lot of, as I mentioned before, there was a lot of additional endpoints that were created, and there was a lot of discussions about this, and then there's still discussions about this at the moment, right? But one example is the mobile JSON wire protocol. This is still in a draft, and you've got touch actions, yeah? So tab, swipe, pinch. One thing I did want to mention, so at the moment, to be able to do this, you have to switch context. Yeah? So you switch to native context, and then you start doing a swipe. Problem with that on a web page is obviously our app goes into full screen mode. So at that point, there's no bar at the top, right? Or if it's not in full screen mode, there is potentially a bar at the top. How do you determine where to swipe? Right? And it's very difficult because sometimes it'll be a guess on, okay, it's 100 pixels down, 200 pixels. It doesn't have a context because it doesn't know about what's in the web view, right? I'll discuss that in the next slide because actually Chrome, with the remote debugger, is actually doing something about this, right? And it sounded quite interesting. It's at the tip of the tree still, but it's something to consider. WebDriver protocol extensions, again, as I mentioned, to be able to install app, launch app, close app, those are all things that are currently being, documented. The really cool one that I personally like and that we really want to use is the get performance data. Yeah? So what that one allows you to do, and the way that it simply works is it calls an ADB command. It comes into std out, so you say, I want to get CPU info for Chrome, yeah? And it shows you the CPU info, and it extracts that from the std out and returns that as a response. What we want to do with that is actually do it every 10 seconds. So as our test is running, our games are quite heavy, yeah? Bingo, poker. We've actually had it where if you leave your test running over time, it eats up 100% of the CPU. Right? So you want to be able to monitor this, and doing that, we can do it on Android devices, and we can actually check it. Not so much on iOS just yet. Right. Oh. Yeah, obviously there are many more. So, what I mentioned in the beginning about the remote debugging protocols and where are the differences, right? Now, a good website for this, come on, is that. And the reason why I want to show you this, and obviously what I would say is please do have a look at this website. It really highlights the difference between all the remote debugging protocols and what's being supported by which browsers. Okay? And this is where some of that pain comes in, because what I mentioned with regards to the browser.close, yeah, it's currently only being supported by Chrome. Now, if Safari supported this, if the other browsers supported this, it would mean, and our automation wouldn't have to do, if I'm on this browser, then run that little bit of JavaScript. If I'm on this browser, then do this, right? So where we have a consistent remote debugging protocols, it would definitely help to make it easier for us to do testing on a mobile browsers. Right, the future of web testing. Oh, sorry. Let's go through some of this, but I actually want to get some feedback from the room as well about where you think the future is going, right? And some of the features you may want to see in the future. So first of all, one of the things that, again, I don't know if some of you have had to deal with this problem, but I'll give you one example. So clearing the browser cache, yeah? And this has been added for Chrome for quite some time, but I know on Safari, with regards to the simulator, what was actually happening is that they were removing the folder on the simulator to clear the cache at a certain point, right? It's like, this shouldn't be the case, right? And I believe right now with XUI tests, we're actually going through the config, manually to clear the cache. It should be as simple as that, right? A remote debugging call that just goes, clear my cache, let's restart fresh, we're done, right? So again, as I mentioned, if we have consistent remote debugging, then this should really help. And hopefully in the future, we will have this. Browser.close, browser.getVersion. So Chrome Debugging Protocol 1.3 was added in Chrome 64. I believe that's about a month ago when that was released. Yeah. One thing is with browser.getVersion, yeah, on Android devices, obviously you've got the OS, plus you've got the different versions of Chrome. So for me to be able to actually pull that version and know on the devices that I'm running, that would really be helpful. And I could actually see that. So it's easy enough to do that with this protocol. Log entries, yeah, JavaScript errors are quite important for us. So again, to be able to, whilst I'm running my test, scrape the console for the log entries for JavaScript errors and actually go, yeah, during my test, why did it stop working? Okay, I took a screenshot. Great, it didn't render or it didn't fully work. Why didn't it fully work? What was the error that was happening? This will allow you to do that. This is what I was mentioning before, synthesize, tab, and pinch. Now, again, once I share the slides, there'll be a link to the, how do you say that, the DevTools protocols for Chrome. This is at what is called the tip of the tree. So it hasn't been released into any of the browser, only probably the ones that's built nightly. What I mentioned, when you, how do you say that? When you switch context and you go into native and you do swipe, because they're going to do it at a browser level through remote debugging, yeah, I should be able to say, on this element, do a pinch in the browser. Yeah? You cannot do that at the moment. You have to calculate, where am I on the page? Where is this element on the page? Okay, it's about height, this. No. This will know where that web element is, and we'll be able to do that pinch. Yeah? And again, this is only currently supported by Chrome, but hopefully some of the other browsers will start taking this on. Final one, yeah. So I don't know if any of you have been doing anything with regards to proxying requests, being able to modify requests on the browser. Obviously, all reasonably painful to do. There is some stuff in the tip of the tree where it allows you to stop a request and actually modify the response. Now, we've been doing this on desktop browsers quite easily because on Firefox and Chrome, you can just say, look, here's the proxy details, go through here, and on that proxy, we'll modify the request. And it allows us to do quite a lot of testing. What happens if you get a 404 or a 500 error? And then it responds in that way. Allows you to do that testing. On mobile devices, it's a bit more difficult. Hopefully, this should help with regards to that. Yeah. Obviously, what I mentioned before, is there anybody here that, the future of mobile testing, like what are features that you guys would really want to see that you're missing at the moment? Nothing? I mentioned them all? Yeah. Sweet, okay, cool. Right, any questions? And again, good?
We got a mic runner.
Sorry.
Hey, hi.
Hi.
Thanks for the presentation.
No worries.
I'm very new to the Appium. So my question is, did you face any challenge or a suggestion you can give while running a test against the emulator versus the actual device?
So did I face any challenges?
Challenges, are there any suggestion for the newcomers? Mm-hmm. So testing against emulator or simulator versus the actual device.
So I'll repeat the question. Did I face any challenges between switching from an emulator to a real device?
Yes.
Most definitely. Yeah, so what I was mentioning before with regards to, at least on iOS, needing a developer profile set up. So to be able to install something on the real device, none of that was needed on a simulator, right?
Okay.
Accessing through the USB port. On Android, it's a lot easier. The ADB, Android debugging bridge, provides you with all of this stuff. You can quickly forward a port on this. None of that stuff was provided on iOS. So it's a lot more of a challenge to test on real devices. We initially were doing a local farm. Yeah, we've now gone with the Sauce Labs mobile device farm. But managing that farm locally, you would come against battery issues, right? So, okay, we were continuously, and mainly tablets. Yeah? iOS, like iPhone devices, they can charge, so that's fine. But the tablets run out of power quicker, right? And they can't charge as quickly. Yeah, there was quite a few challenges. And again, for us, it was very important to run on physical devices, right? Because we wanted to know, as I mentioned, does my device run out of memory? Does my device run out of CPU? How well does it perform? One thing with games as well, frame rate is important, right? When I, how do you say that? When I do a big win for a slots game, a lot of graphics start appearing, right? And on the older devices, the frame rate drops right down. So we need to check on real devices if that's how that works.
Anything with respect to using the APIs like finding an element or clicking on a link, anything with respect to, is there any difference between these emulators and the actual?
No.
Okay.
To be honest, that should be fairly straightforward and fairly simple. So with regards to the atoms, right, it's just executing JavaScript. So whether it does that on an emulator or on a real device, minimal difference.
Sure. Thank you.
Yeah? Sorry, I do apologize. Do I have enough time?
Yeah, can we do it maybe offline? I don't want to keep you from lunch. I know it's late. Lunch is going to start now.
I'll sit down with you offline and
maybe
we
just
discuss.
ask offline. So lunch is in Embarcadero.
Thank you.
Yeah. Thank you, Sergio.
Thank you.